Good morning, everyone. Today we are doing time value of money. So, what does time value of money actually mean? Time value of money means a rupee received today is more valuable than rupee received later. What does this mean? Let us suppose you receive rupees 1000 today, or you have an offer to receive 1000 rupees after 1 year. Which one will you choose? It is very natural you will ask someone to pay 1000 rupees today because you don't know what will happen in future is very risky, right? So a rupee received early on is much better than rupee received later. When money is received after some point, it loses its value. It also means that money received at different time periods has different value. For example, someone gives you rupees 1000 in the beginning of year. This is called as year 0 or year 1 or year 2. Now these 1000 received at different time periods are different values. You cannot have same values for them. And as money is received later, it loses its value due to various reasons. These reasons are inflation. Because of inflation, you lose value of money, purchasing power changes, opportunity cost, and interest. That is, you could have invested this money somewhere and got an interest, or you could have invested this money and got some returns. So you are losing this value because you are receiving same amount at different time periods. So now we cannot have the same benchmark for different time periods, and hence we need to have a common scale when we want to measure the value of money. And that is why we use various tools of time value of money. And there are two important procedures in time value of money. One is compounding. Compounding essentially means when you are given a present value and you are required to find out its future value. Basically, you are told that suppose you have 1000 rupees today and you are asked to find out what will be the value after, let's say, 3 years. So you will invest 1000 today and you will keep on getting interest for 3 years, interest on interest also, which we call it as compounding. So this process is called as compounding. Okay. Now suppose, just for an example, suppose you invest, this is a timeline, year 1, 2 and 3. Year 0 means today. Okay. In time value of money, year 0 means today. Suppose you invest rupees 1000 today and you are asked what is the value at the end of year 3. Okay. So what we will do is basically 1000 is nothing but your present value, what you have now, what you have invested today, and what you will find is the future value. So this is an example of compounding or finding future value. Okay. This is called as compounding or same as future value. Now sometimes this was a single amount. In the above example, 1000 for one time. It is also possible that you invest, let us say, year 1, year 2, year 3 and year 4. Let us say you invest 1000 every year for 3 years and you are asked what will be the future value at the end of 4th year. Okay, so this is also called as compounding because you are finding future value that is at the end of 4th year, but this amount is called as, since you are investing 1000 every year, same amount every year, this is also called as future value of annuity. Future value of annuity. Okay, these are just examples. We will go for examples one by one. Okay, now let us see some. Okay, before we go to examples, see, there is a PDF attached in description box. This PDF is called as financial tables. Okay, so we will be using financial tables to solve example of time value of money and capital budgeting as well. So you need to be thorough with these financial tables. Okay, now see, there are various tables in it. Let us start with table A. Read the title of table A. Table A is compound value of lump sum of rupee 1. Now what does lump sum means? Lump sum means a single amount. You invest an amount just once. Okay, a single amount. This table in short form is also called as FVIFA, at R percentage for n years. What does this mean? This means it is future value interest factor. Sorry, not FVIFA, it is just FVIF. Future value interest factor at R percentage for n years. Okay. Then you see there is table B. How to use these tables I will show you with examples. There is table B. Table B is compound value of annuity of rupees 1. This is called as annuity factor. Okay, so when we use annuity factor and compound value, so when we have annuity means same amount every year. Okay, this is called as FVIFA, at R percentage for n years. This is called as future value of interest factor for annuity at R percentage for n years. Okay, so right now you have to remember two things. How to apply them, we will see in examples. The first one is FVIF and second is FVIFA. So when you are required to find out future value of single amount, you will use FVIF. When you are asked to use future value of annuity, annuity means same amount every year. Okay, you will use FVIFA, that is future value interest factor for annuity. Okay, now let us have a look at examples and see how to apply this. Okay, so see example number 1. Mr. A deposits 10,000 at 10% interest compounded annually. So here Mr. A has deposited 10,000 at 10% interest. So present value is rupees 10,000. Interest rate R is equal to 10%. We also call this as 0.10. 10% is 0.10. How much will he get at the end of 3 years? And how much will he get if he holds this for 5 years? Okay, So let us have a look at how do we solve this with formula. But instead of formula, what we will focus on is how to use tables to find the answers. So first of all, present value is given to you because you deposit 10,000 today and you are asked how much will you have after 3 years. It means what is asked is future value. You are asked future value, and future value is present value into 1 plus r raised to n. Okay, so this is very simple. So 10,000 into 1 plus r is 0.10, and raised to n is, let us say, 3 years, because you are asked at the end of 3 years. So if you solve this, you will get 10,000 into 1.331 is equal to rupees 13,310. This was with formula. But instead of formula, what you can do is you can use table. So how to use table? Future value, let us say at the end of year 3, I am calling it as FV3, is equal to present value. Now instead of 1 plus r, what you have to write is, since this is, see, there is only one single amount and you need to find out future value. So we will multiply with future value interest factor, FVIF. At R percentage, your R is 10 percentage and N is 3 years. N is 3 years. Now look at, I'm just, look at table A. Okay. And in table A, see 10 percentage and 3 years. You will get the factor. So present value is 10,000. If you look in table A at 10% and 3 years, the factor is 1.331. So your answer is rupees 13,310. So whether you use formula or you use table, you will get the same answer. Now try it for 5 years. If how will you find it for 5 years? So future value at the end of year 5 is equal to present value into FVIF at 10 percentage for 5 years. So 10,000 into FVIF, that is future value interest factor. So you see table A, 10 percentage and 5 years. It is 1.6105. So your answer will be 16,105. So if you basically, what does it means? If you invest 10,000 today, after 3 years with interest and interest on interest, you will have 13,310 after 3 years and 16,105 after 5 years. Okay. So this is an example of what we call it as compounding or future value of a lump sum. Future value of a lump sum. Lump sum means only one single amount. Okay. Now see example number 2. In example number 2, you have multiple lump sums. Multiple lump sums means, read the example first. Mr. C, Miss C has invested 1,000, 3,000 and 2,000 at the start of year 1, 2 and 3. So Miss C is investing these amounts in the beginning of the year, and see these amounts are different every year. So three different amounts she is investing at 3 different time periods. She receives 12% interest compounded annually. What is the compounded value of her investment at the end of year 3 or third year? So you have to find out what is the value of her investment at the end of year 3. So if I want to make it simpler for you, what I'll do is I'll draw a timeline. So let us draw a timeline. At the start of year 1, she is investing 1000. Then at the start of year 2, she is investing 3000. At the start of year 3, she is investing 2000. This is start. Okay. And you are asked what is her value at the end of year 3. Okay. So you have invested 1000 in the beginning of the year, 2000 in beginning of year 2, and 3000 in the beginning of year 3. So how much will you have at the end of year 3? Now see, you have to find out compound value of these three amounts. So how much will be 1000 at the end of year 3? How much will be this 3000 at the end of year 3? And how much will be this 2000 at the end of year 3? So let us say you invest 1000 in the beginning of year 1. What will be the value at the end of year 3? So you have 3 years of compounding. 3 years of compounding. Okay. So how do you find out compound value? Future value is equal to present value 1 plus r raised to n. Okay. So 1000 into 1 plus r. R is your interest rate, which is 12%. So instead of 12%, I can write 1.12. 1 plus r, so 1 plus 0.12 is 1.12. Now if you invest today and at the end of year 3, it means there will be compounding that will happen 3 times. So basically you will receive interest for 3 times. So find out the value of 1000 into 1.12 raised to 3. It will be 1404.9. Okay. Similarly, this 3000 rupees which you invested in the beginning of year 2, this will have interest, but from year 2, start of year 2 to end of year 3, it will be compounding only twice. So 1.12 raised to 2, this will be 3763.2, and 2000 in the beginning of year 3 till end of year 3. So from beginning of year 3 to end of year 3, you will get interest of 1 year. So 1.12 raised to 1, it will be 2240. Okay. And if you make a total of all of 3, you will get, what will be the value? You will get 7408.1. So if you deposit 1000, 3000 and 2000 in the beginning of year 1, 2 and 3, this will be your future value at the end of year 3. You can call it as future value, compound value, whatever you want. Okay. So this is an example where you have different amounts every year. Okay. So it is nothing but multiple lump sum amounts every year. So you have to just find out future value of each lump sum and make a total. That is it. Okay. Now, sometimes you invest same amount every year. And when you invest same amount every year or every month, it is called as an example of annuity. Now, annuity are also of two types. One is when annuity or when investment is made at the end of year. It is called as ordinary annuity. Sorry. It is called as ordinary annuity. Ordinary annuity. Ordinary annuity means same amount at the end of every year. Okay. So see, read the question. Mr. A has started investing rupees 5000 at the end of each year. So from here you know that investment is made at the end of each year. So A is equal to rupees 5,000. End of each year at interest rate of 10%. So R is equal to 10% or 0.10. For 5 years, N is equal to 5 years. What will be the investment at the end of year 5? Now you can solve this example with either formula or you can solve with tables. Let me just write formula first. So you need to find out future value of annuity at the end of year 5. So formula is A into 1 plus R raised to N minus 1 upon R. If you plug in all the values, it is very simple. You plug in all the values, you will get the answer. Okay, but my focus here is to teach you how to use the tables. So instead of this, what you can write is A into whatever is written in the bracket, you can substitute it with FVIFA at R percentage for N years. FVIFA means future value interest factor for annuity. Since here it is annuity and same amount is received every year, we will use annuity factor. Okay, so let us use annuity factor. A is 5,000. Now how do you get this annuity factor? You will get from table B, compound value of annuity. So see in table B, and in table B you have to see 10% and 5 years. So you will get 6.105 as factor and your answer will be 30,525. You can try it with formula also, you will get the same answer. Okay. However, formula you have to remember a lot, but if you know the logic, you can use table and you can further simplify it. Okay. Unnecessary complications you can avoid if you know how to use the tables. Okay. So again, a very quick revision. In this question, you had 5,000 rupees every year, and since it is every year, it is called as annuity. It was at the end of the year, and it is called as ordinary annuity because amount was invested at the end of every year. And since it is annuity, what we use is called as FVIFA. This you will get from table B, future value interest factor for annuity. Okay, so just look at table B, 10% and 5 years, and you will get the factor multiplied with annuity. What does this mean? If you invest 5,000 every year, okay, at the end of every year, after 5 years, what will be the, and you get 10% interest, what will be the amount in your bank account? It will be 30,525. This much amount you will accumulate in your account. As simple as that. Okay. Now let us come to next question. Okay. Now see, there is another type of annuity which is called as annuity due. Annuity due means when the amount is invested in the start of year or beginning of year. Okay. In previous example we saw amount was invested at the end of year. So it was called as annuity ordinary. This is annuity due where amount is invested in the beginning of the year. Okay. Now see, it is very simple. Mr. A started depositing money in the beginning of 4 years, starting from now. So you know it is starting from now, beginning of the year, it is annuity due. What will he receive if after 4 years, if he invest for 10,000 rupees each year? So he is investing 10,000 each year and not once. So this is annuity 10,000. R is equal to 10%. N is equal to 4 years. Now I am writing formula, but we will solve it with table. So the formula is A. Sorry. future value of annuity after 4 years is equal to A into 1 plus R raised to n minus 1 upon R into 1 plus R. Okay. Now, how to use with tables? FVA after 4 years is equal to A. This formula in the bracket will be substituted by FVIFA at R percentage for n years into 1 plus R. Okay. So basically, this formula is your annuity ordinary. A into FVIFA R percentage for n years. What you have to add additionally in this formula is multiply by 1 plus R. So A is 10,000. FVIFA, you will have to find out at 10 percentage for 4 years from table B, multiplied by 1 plus R is 1.10. So 10,000 into, look at table B, FVIFA at 10% for 4 years, answer is 4.641 into 1.10. So your answer will be rupees 51,051. Yeah. So this is the difference. The only difference between ordinary and annuity due is 1 plus R. Basically, it means that you will, if you start investing in the beginning of the year, you will get an extra interest rate. You will have one more compounding. Okay? So that is why we multiply it with 1 plus R, which simply means that you will have one more extra compounding, or you will get an extra interest. Okay? So this was compounding. Okay? Now in the next video, we will look at all the discounting examples.